Okay, so let's work our way through the test review. Step one is to convert the equation that's given into slope-intercept form. To do that, we're going to do really just two steps here. It's in point-slope form, so we're going to distribute the 1/6 to what's in parentheses, so we have 1/6 x plus 2, and then we're going to add 4 to both sides, and our answer is y equals 1/6 x plus 6. Number two, we're going to convert this equation into slope-intercept form. Same thing. Y plus 7 equals 2x minus 8. Subtract 7 from both sides and get y equals 2x minus 15. Let's convert this equation to slope-intercept form. Here, the y is already by itself, but it has that 5 there. So we're going to divide each term by 5, and we get y equals 3/5 x minus 2/5. Easy enough. Number 4 asks us to convert, again, slope-intercept form. Here we have to get the x on the other side. Mistake here often is that we don't bring the sign over with it, and we don't leave this sign. So this is negative 4y equals negative 3x plus 12. And then we're going to divide everything by negative 4. And we get y equals positive 3/4, because a negative divided by a negative is a positive. The positive 3/4 x minus 3. Slope of the line, depending on how you do this one, it might look a little bit different. Too far. I prefer change in y over change in x. So the change in y here is 3. The change in the x is 4. With a quick sketch of the graph, I can see that negative 2, 5 is here. Negative 6, 8 is here. So this line is going down, so the slope, which is m, is negative 3/4. Number 6 asks you to write the equation of the line with a slope of 4 that passes through the point negative 7, 1 in point slope form. To do this, you just have to know point slope form, which is y minus the y value equals the slope times x minus the x value. Here the x value is negative, so this is plus 7. And that's all you have to do, but you got to know point slope form to do that. Number 7, write the equation of the line that passes through the points 5, negative 6, and 8, 6 in point slope form. Similar to the one before this, but we have to find slope. So the change in y is 12, the change in x is 3, and then quick sketch tells me that, let's see, we have 5, negative 6, and we have 8, 6, so this is positive. So the slope here is 4. And then I just pick one of the points. Y plus 6 equals 4 times x minus 5, or y minus 6 equals 4 times x minus 8. Both answers are correct. Okay, number 8, write the equation of the line that passes through the points 2, negative 3, and negative 3, negative 4 in slope-intercept form. So here, find the slope first. We have 1 over 5, and again, the quick sketch, 2, negative 3, negative 3, negative 4. It's positive, so that's the slope. I'm going to use point and slope form because I think it's the easiest way to do this. 1/5 times x minus 2. I'm going to distribute the 1/5. And then I'm going to subtract 3. Now be careful here. You have to subtract 3 from negative 2/5. If you're not sure how to do that, the easiest thing you can do is go ahead and open up your calculator. Most of you have a calculator that'll do this pretty easily. This is negative 2/5 minus 3. And it gives it to me as an improper fraction, which is fine, negative 17/5. Slope-intercept form again here. I'm gonna go through point-slope form because it's just, we have to know it anyway, and this is why, because it makes the problem easier for us. We'll distribute. Be careful there, negative times a negative, and then add 5 to both sides. Number 10, vertical and horizontal line that passes through that point. This is just a fact you have to know. A vertical line is always x equals a number. That's the vertical line. The horizontal line is always y equals a number. Nothing to do there, just stuff we got to know. The slope of a line parallel to this line, parallel lines have the same slope. So the answer is just m equals 3. Number 12, the slope of a perpendicular line, that's the opposite reciprocal. Opposite and reciprocal, so negative, and then we flip the fraction. Notice I didn't put x after either one of those, it's just the number. Okay? The slope of a line perpendicular to the line x equals 5. Well, x equals 5 is a vertical line with a slope of undefined. The perpendicular line is horizontal. Horizontal lines all have a slope of 0. Which equation illustrates a direct variation? Direct variation has to be in the form y equals kx. This has a y-intercept of 3. This is going to have a y, oh not 3, sorry, 3 halves. This is going to have a y-intercept, and this one has a y-intercept. The only one that doesn't is C, so your answer is C. Next page. Given the scatter plot below, draw the line of best fit and write the equation in slope-intercept form. To do this, I'm going to use a straight edge because I want to make sure I get some form of straightness to my line. And then it's not going to be the same. Yours might not be exactly the same as mine. It's going to look something like that. So I've drawn the line of best fit, and then I'm going to pick 2 points. Okay, I'll use this point down here and this point down here. So this is a rise of 3, 6, 9, 10, and it's a run of 3, 6, 8. So the slope I got, always reduce, is 5/4. And then the y-intercept is about 2. Now, is that exactly right? No. But this is an estimate. Okay, lines of best fit, when we draw them by hand, those are estimates. And let's move the equation down here to where it goes. You're jealous that you can't do that on your paper. Okay, now for this, I have to have a graphing calculator. Make sure you have your calculator for the test. Make sure you know how to use it. Okay, I'm going to go ahead and put the data in first. So I have, go to my menu, into stat. The x values are 5, 10, 15. The number one mistake here is input error. 20, 25. Move this over so I can see. 30 and 35. So there's my x values. The corresponding y values are 36, 34, 32, 30, 29, 28, and 26. Okay, so I've got all that in. Find the equation that most closely represents a line of best fit for the data. I'm going to go ahead and take this into calc. F3 for linear regression, F1 for x, and there's my values. Okay, so I have, and we'll round it to the 100th just to be easy. We'll say y equals negative 0.32. And then the y-intercept was 37.14. Easy enough. Use the equation you found in the previous question to estimate the wind chill if the wind is blowing 60 miles an hour. So I bring this back up. Remember, if I have a TI, it copies it for me. If I have a TI, it doesn't copy it. In the Casio, it does copy it. So I'm going to copy that into my graph function. Go back to menu. Go to number 5, which is my graph. There's the equation I need, and I forgot to hit F1 to select, so if that happens to you, that's what the error is. And I'm going to graph it. I can't see it right now. This happens to us a lot. We have to change our view window. My x values go from 0, and I'm going to calculate up to 60, so I'm going to go ahead and put 70 in here. And then my y values go from, the biggest one is 36, so we'll say a minimum of 0, and we'll go to 40. Draw that. There's my line. Then I'm going to go to Shift F5 for the G solver, F6 to choose over, and I'm doing a y calculation because I'm given the x. So the y calculation when the wind chill is 60, and that's 17.86 degrees. Use the correlation coefficient, the R, to determine how well the equation models the data. What is the value of the correlation, and is it a good model? So let's take a look. The value, we'll go back to the stat menu. The correlation coefficient here is 0.99, negative 0.99. Which we said it's a good model if it's close to 1 or negative 1, which this is very close. So there's that. Let's take a look at page 4. Which of the graphs illustrates a direct variation? This you just have to know. A direct variation always goes through the origin, so the answer is B. Which of these tables is a direct variation? A direct variation, the k value is y over x. So y divided by x has to be the same every time. Let's look at A. 3 over 1 is 3, 4 over 2 is 2. I instantly know that that's wrong. B, 4 over 1 is 4, 8 over 2 is 4, 12 over 3 is 4, 16 over 4, so B works. I'm going to continue checking just to make sure. 5 over 1 is 5, so that's not right. And D, negative 1 over 1 is negative 1, so that's not right. The easiest way to look at number 24 is to try and determine what is the independent variable and what is the dependent variable so that you know which is the y and which is the x. Okay? For miles per gallon, we're literally going to think of that at, well, first let's do this. We can eliminate D as an answer because it's not right. So let's take a look. We know that we're talking about a direct variation. So we're looking for y equals kx. In this case, this is y equals k over x. So that's no good. B is y equals x over k. So that's no good. Miles would be the y. Gallons would be the x. This is y equals kx right there. Number 25 says, assume that y varies inversely with x. So inverse variations are in the form of xy equals k or y equals k over x. An inverse variation equation, if y equals 8 and x equals 6, is very simply xy equals 48. Number 26, the time it takes to complete a go-kart race course is inversely proportional to the average speed of the go-kart. One rider has an average speed of 73.3 feet per second and completes the course in 30 seconds. Another rider completes the course in 25 seconds. What was the average speed of the second rider? So we need a constant variation equation, and then we're going to plug 25 into what we get. To do that, for the first one, we need to know the constant. That's going to be 73.3 times 30. That's our x and y. So let's get our calculator back out. Multiply 73, go back to my menu, into run. 73.3 times 30 is 2,199. So our equation is now xy equals 2199. Here, I'm given 25 seconds. I want to know the feet per second. So that's the x. So 25y equals 2199. Back to my calculator again. Take that number, divide it by 25, and I get 87.96. And that's 87.96 feet per second. And you're done with the review. Good job.